multi-layer network and the back propagation. So let us consider example the speech propagation. So input values of the speech is given, and the aim of the input is to get the output which word has been spoken. So that is one of the application of multi-layer network. So the input is given and identifies what word is spoken. So like this, the input of the multi-layer network is taken, and there are weights that is being given, and these weights are specified, which is at the beginning it is taken randomly, and then the middle layers is called the hidden layer, and then the output is calculated. Now these are the inputs. X1 to Xn are the inputs, and W0 to Wn are the weights, and have a sigma of I equals 0 to n is equal to WIF into Xi equals n net, and that is equal to sigmoid 1 over 1 plus e power of minus net. So that is the hidden layer value is calculated. So understanding the back propagation algorithm, so until the termination condition is met, do. So that means until the target value is achieved, then repeat the back propagation algorithm. So steps: input the instance to the network and compute the output of the training every unit U. For each network output unit K, calculate its error term delta K. So this is the output, network output, and the error term, that is equal to OK into 1 minus OK into Tk minus OK. So OK is the output we have got, and Tk is the expected output. Now for each hidden unit H, calculate its error term delta of H. So delta of H equals OH into 1 minus OH sigma K in WKH into delta K. Update each network weight, that is W of Ji equals W of Ji plus derivative of W of Ji, where derivative of W of Ji equals eta into delta J into X of I. So net is the sigma of all the values, and that is the linear unit, and this is the input is given, and that is the sigmoid is calculated 1 over 1 plus e power of minus net. So let us consider the back propagation example and calculate the values of it. So here 1 and 3 values are calculated by the sigma value, so that is minus 1 into 0.85, minus 1 into 0.85, 1 into 0.6, 1 into 0.5, 1 into that is 1 into 0.5, this one 0.5, 1 into that is 2, this is 1 into 0.5, so the value of it, so that is equal to 0.25, that is equal to 1 over 1 plus e power of 0.25, that is equal to 0.5621. So the value we are getting is 5621, and then 1 4, so 1 and 4, so 1 and 4, so it is 1 and 4 is 1 into 0.8 plus 1.1 into 1, this 1.1 into 1, that is towards 4, and this is minus 1 into minus 0.15, minus 1 into minus 0.15, so it's equal to 2.05, that is equal to 1 over 1 plus e power of minus 2.05, that is equal to 0.885. So 0.885 we calculate. So this is the value 0.5621, 0.5621 and 0.8859. This is 8.59. So we calculate, and the value of this, so 35 value, so x of 35 is 0.5621 into 1.25, this will be minus 1.25, and it is 0.8859 into 1.2, this is 0.8859 into 1.2, these two and these two multiplied and added it, that is sigma, minus 0.35 into minus 1, so it equals 0.0 0.1048, 0.01048, 1 over 1 plus e power of 0.01048 equals 0.5626, 5026. So 0.5026, so that is what we get, 0.5026. so the value, this is sigmoid, this is sigmoid, and this is sigmoid of these two, and the error is equal to e, small e equals 0. This is the expected value and this 0 is the expected value, and what we are getting is positive. So we have for XOR, if it is 1 1 is the input and the expected output is 0, but here we are getting 0.5026. So the expected output is 0.5026 and we need to reduce it to 0. For that we do back propagation. That means changing all the weights, and we do the same thing again, that is back propagate to change all the weights and then forward, back propagate and then forward. So this process is repeated until we get 0. So now let us start with the first back propagation. So delta d, that is the overall value, okay, the overall value of it, overall error term. So it is equal to 0.5026 into 1 minus 0.5026 minus expected value into minus 0.5026. So 0.5026 into 0.4974 minus of 0.5026, that is equal to minus 0.1256. This is the network error term. Now the obtained is the network error term. So this can be used in the later section. So this is the network error term here. W of ji equals W of ji plus derivative of wi ji equals derivative of wi ji equals eta into delta d into x of I. So that will be equal to derivative of 3 equals 0.1 into 0.5621 minus of 0.1256, which we just calculated, we get minus 0.007. So this becomes 0.5627, so 257 minus 257. So the new obtained value minus this weight is changed to minus 1.257, minus 1.257. The new weight that is calculated is minus 1.257. So and the theta and the eta value is 0.1. That is the learning rate. So that is this value. This value is 0.1. That is the learning rate. So it depends, the speed increases as we increase this weight, and this is between 0 and 1. So here we have given the 0.1, and the weight changed is very slow rate. So it is at the learning rate is very slow, and that is why we are getting 1.25 to minus 1.257. So not much difference, but there is a difference. So next value is, again we have this delta d equals the OD 1 minus OD into TD minus OD. So this is the value we get minus, this is the network error, complete network error term, minus 0.1256 is calculated, and again eta into DD, eta into delta D into x of I. So that is for derivative for 4.5. So 4.5 value is calculated 0.8859 into 0.1 equals minus 0.1257. So this value is calculated, that is 4.5 is equal to W of 4.5 into derivative of ji is equal to 1.0887. So that is this value. That is 1.22 is changed to 1.0887. So it should be 1 point. So we minus, and so it is correct, 1.2 to 1.087. Now we'll change 0.35. So again same thing here, the error term or network error term is equal to minus 1.2 0.1256, 0.1256, and the derivative of ji is equal to eta into delta d into x of I. So that is derivative of 5 is equal to 0.1 into minus 1 into minus 0.1257. So it is equal to 0.1256, 0.01256, and this is equal to 0.35 plus 0.01256, and we get this new term. There is 0.035, 0.35 to 0.3625. Now these values are calculated. These values are calculated by just derivative of w of j, that is by this value, by just subtracting this value. But now we need to we'll calculate for the hidden values. These 3 and 4 we'll try to calculate for the hidden values. The formula is bit changed from the algorithm. So the what is changed is we are trying to calculate the hidden value. So hidden value is big OH. So we know delta D equals minus 0.1256, which we calculated, and O3 equals 0.5621, that is OH, that is the obtained value. 562H, that is 3 value, that is exactly 3 value 5621, and delta H equals 0. That is OH into 1 minus OH into sigma WH into delta D. So this delta D is this delta D, and WH is the weight between the so network. So we calculate this 0.0386. And now remember this, what is this WH? WH is 1.2. So we get it here, and then after we calculated 1.2, and we calculate eta into rho h into x of I, and this 0.1 into this value, and this is the new value. So we are using, to calculate the hidden value, we are using the complete algorithm of the back propagation. So in the complete algorithm there are 3 formulas, that is this for delta D, and this is for hidden layer, and this is for derivative of W. So we are using all the 3 for the hidden value. See here, so this 3 we are trying to calculate the weight of this 3, that is for 0.6. Weight of these 3, that is this 3, it is the hidden value. So from 1 and 3 this weight is calculated by taking the weight of this, that is minus 1.5, and the sigma of this minus 1.5, that is we are using this value, we are using this value, and we are using this value 0.6 minus 1.25 and 0.5621. So all the 3 are used to calculate this weight. For this weight, so that is what hidden value, to calculate the weight of the new derivative weight of this hidden value. So we use all the 3 formulas of back propagation. So what is this, all the 3? The first one is, so we calculated that minus 1.2 is the weight, this minus 1.2, this one minus 1.25, this will be 1.25. okay, so this is 1.25, and we calculated this value. So O3 is the value. This is 0.5621 is the O3 value, 0.5621, and 0.6 is this value. 0.6 is this value. So 0.6 plus this delta t, there is a derivative of 1 and 3. So and we calculate the 0.6. So new weight that is formed is 0.6 to 0.6 and the next value 0.687. Okay, now we need to calculate what is the derivative of 4. What is the derivative weight of 4? So that is for, we change for 1 we'll see 0.889. so that is what we take here is, in this while calculating is, we take this value, we take this value, and we take this weight, this value, this weight, and this weight to calculate the weight, one weight here. So either we calculate this 1.1 or 0.1, we use this 1.2. So that is the sigma, that is the sigma of weight of the next previous one. So that this will be 1.2, so this will be 1.2, so that is this value 1.2. that is, to calculate this, the sigma of the previous one. To calculate the next one, we are coming from this side, so from back we are coming. So if you want to calculate this, we take the sigma of the previous one. So 1.2 is the sigma, so not the new value, the previous value. So that is 0.8859 into the sigma value minus 0.1256, that is delta D, into 1.2. So this is 0.8859 into 1 minus 8859. So this is the new delta H. So that is equal to derivative of W of Ij, Ji equals eta into delta H into X of I. So delta derivative of 1 and 4 equals 0.1 into 1 into minus 0.0152. So that is W of 1 4 equals W of 1 4 plus derivative of W 1 4, and this value is 0.7984, and this is the new value we got is for this 0.8. So actually we calculated for this 8. So till here it is the same, and for this so we have taken for 8 1 and 4. This is 1 and 4, 0.8, 0.5. So now the next one is we calculate for 2 3. We calculate for 2 3, the same one. So the big O of 3 is equal to 5621 and 0.0386, and derivative of W is equal to eta into delta H into X of I is 0.1 into 1 into 0.0386, and this is 0.5 0.0386, and that is 0.5, and the new value formed is 0.5 is to 0.586 is the new value, that is we have got 0.586. And now delta D equals minus 0.156, and big O of 3 is 0.5621. So delta H equals delta H 0 big O of H 1 minus O of H into sigma WH into delta H, and this value is calculated, and W3 and you get 0.85 is changed to 0.8461. So this value is changed to 0.8461. Now we'll try to calculate for the next value 2 and 4, and the 2 and 4 value is 1.1. So here OH is 0.8859 and 0.8859 into 1 minus 8859 into minus 0.1256 into 1.2. This is we get this value, and derivative of W of Ji equals eta into delta H into X of I, and that is this value. This value is changed here. This value is changed to 1.1 to 1.094, 1.098. So it is changed to 1.098, and to calculate this we used this 1.2 and 1. So this 1.1 value. Okay. So now this is not the final step, because our learning rate is 0.1. So this we do a forward access now with these new values, and the new output is calculated, and again back propagation is made and the new values is calculated, and then again be a back propagation is made, and totally because we have given the learning rate is 0.1, so there are many more number of back propagation is made, and finally we'll get an exact weight which specify what is the output, that is 0. To reach 0 from 0.5026 to reach, it takes more than 5 steps. Okay, thank you.